Hello and welcome to another screencast at Phuket Pals with Live at Pals. Today we will have a look at a IGCSE Chemistry multiple choice paper. Specifically, we will look at the 2023 Specimen paper, multiple choice. So let's get started. The first question on this paper is about temperature changes and changes of state. A gaseous substance is slowly cooled at the temperature recorded every second. The results are shown in the graph. At which point is the substance a solid? The question tells us that it starts as a gas, so that means at the beginning, up here, it's going to be a gas. Then at B, our substance is condensing, which means we have in this region a gas and a liquid at the same time. So the temperature doesn't change until all the substance has changed state to liquid. And then the temperature is further decreasing. So right here we have a liquid, and then in D we have partially liquid and solid. So that means at D the substance is at least partially a solid. Second question. A gas is released at point Q in the apparatus shown. We have a damp universal indicator paper at the end. Which gas changes the color of the damp universal indicator most quickly? We are given the gas and we are given the relative molecular mass. We know that the lighter a molecule is, the faster it diffuses at the same temperature. This has to do with the kinetic energy formula, which you maybe know from physics, that kinetic energy object is equal to a half times its mass times the velocity square. And we know as well that temperature is equal to the average kinetic energy of the particles of a substance. That means the lighter a particle is, or the lighter the particles of a substance are, that means the mass part of the formula is decreasing. And if we have two different gases at the same temperature, that means they have the same average kinetic energy. If we have a light gas, it has less mass, and therefore it must have a greater velocity. So light particles at the same temperature are diffusing faster than heavy particles because their velocity is greater at the same kinetic energy or average kinetic energy. So we have a little trap here. We see that hydrogen is the lightest gas. However, hydrogen is not an acid or a base, so it will have no effect on the damp universal indicator paper. So we are looking for something that would change the color of the indicator paper, and ammonia and chlorine do this for sure. Carbon dioxide maybe a little bit, since it's a slightly acidic gas, but ammonia and chlorine definitely change the color of the universal indicator paper. Ammonia is acting as a base. Ammonia is NH3. It can accept hydrogen ions to form ammonium. Therefore, it is a base. It's a hydrogen ion acceptor, and it will change the color of the universal indicator paper to blue. And chlorine would bleach the universal indicator paper. However, ammonia is the correct answer here because it has lower mass than chlorine and will diffuse faster. Question 3. Which statement describes the bonding in sodium chloride? A shared pair of electrons between two atoms leading to a noble gas configuration, a strong force of attraction between oppositely charged ions, strong force of attraction between molecules, a weak force of attraction between oppositely charged ions. So, sodium chloride, sodium is a metal, chlorine is a non-metal. Metal and non-metal together form ionic compounds. Therefore, we can exclude answer A, because answer A talks about sharing an electron pair. That's a covalent bond. That's not happening in an ionic compound. So that means we can as well exclude C, strong force of attraction between two molecules. We don't have molecules here. We have ionic compounds. And so it's either B or D, and the force of attraction between oppositely charged ions is a strong force. So that is answer B. Next question, number 4. The lead in a pencil is made of a mixture of graphite and clay. When the percentage of graphite is increased, the pencil moves across the paper more easily. Which statement explains this observation? So the greater the part or the percentage of graphite, the more easily the pencil slides over the paper. We do know that graphite is made of layers that can slide over each other, and therefore graphite has lubricating properties, and this is as well the correct answer here. Graphite is a lubricant. Some statements are correct here as well. Graphite is a form of carbon is a true statement. Graphite has a high melting point is a true statement as well. And it's a non-metal, that's true too. But the explanation why the pencil moves across the paper more easily is that graphite is a lubricant. Number 5, which statement about metals is not correct? They conduct electricity because delocalized electrons can move through the metal. They consist of layers of atoms that can slide over each other. They have a giant lattice of oppositely charged ions in a sea of delocalized electrons. They have a giant lattice of positive ions in a sea of delocalized electrons. So we can see just by reading the answers, it's probably either C or D because the statements are more or less the same. The only difference here is that it says a lattice of oppositely charged ions in a sea of delocalized electrons, whereas here it says giant lattice of positively charged ions. The other two are definitely true. No, here conducts electricity because delocalized electrons can move freely through the metal. That's definitely correct. Metals do consist of layers of atoms or positively charged ions that can slide over each other. That's true as well. That's why metals are malleable and ductile. So it's either C or D, and I already gave the answer away. In a metal, the metal itself is made of a giant lattice of positive ions and a sea of delocalized electrons. So therefore the wrong statement, the statement that is not correct, is C. It's oppositely charged ions we find in an ionic compound, but there would be no sea of delocalized electrons. So that's what we find in metals, because the metal atoms all give away electrons into the spaces between the atoms, and the atoms then form positive ions. And all of this is held together by the negative charge of the delocalized electrons and the positive ions attracting each other. Number 6. Aqueous iron 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. What is the balanced symbol equation for this reaction? Iron 3 sulfate reacting with sodium hydroxide. What makes sense here? So the formula is always the same, okay, so they give us the correct formulas in every case, so we only need to balance the number of atoms correctly. So we can see that in the first two examples, here we have an A and B. In both cases we have 2 irons in Fe2. However, here we have only 1 iron, so we can exclude A and B. In C, this is correct. We have 2 irons here and 2 irons here. And we can check D actually. Here we would have 4 irons, 4 irons. Okay, so let's see which one is correct. Let's C or D. 2 irons, 2 irons. That means we have 3 sulfates, and that is correct here as well. 3 sulfates, which makes it 3 times 2, 6 sodiums, so 6 NaOH is correct as well. And we have 2 times FeOH3, so we have 2 times 3OH, which is 6 as well. So C looks balanced to me. So that is the correct answer. We can see that 6 and 6 here will not add up. That would be a total of 12 sodiums, but here we have only 6 sodiums, so that's why D is not balanced. So C is the correct answer. Which information is needed to calculate the relative atomic mass of an element? The total number of protons and neutrons in the most abundant isotope, the nuclear numbers and the total number of isotopes, the nuclear numbers and the total number of isotopes, the mass, number and abundance of each isotopes, the atomic number and the abundance of each isotope. We need to know the mass number, which is the same as the nuclear number. So nuclear number and mass number is the same thing. Same as the total number of protons and neutrons, it's basically the same thing as well. So that's these 3 here actually are talking about the same stuff. Only down here it's talking about the atomic number. Atomic number is not needed. Isotopes are about, an isotope. Isotopes are atoms of the same element that have different mass. So we need the number of protons and neutrons, because protons and neutrons both have mass. Electrons have no mass, so protons and neutrons make up the mass of an atom. So we need to know about these. Plus we need to know about the isotopes. And what do we need to know about the different isotopes? We need to know about the abundance of each isotope. Abundance refers to the proportion of each isotope, how common it is, the percentage of each isotope in a sample of the substance or the element. And then we can apply a formula to find the relative atomic mass that takes into account the masses of the different isotopes and their abundance. So the correct answer here is C. Number 8. The equation for the reaction between sodium carbonate and excess dilute hydrochloric acid is shown. Na2CO3 plus 2HCl gives 2NaCl plus H2O plus CO2. When 26 gram of sodium carbonate reacts with excess dilute hydrochloric acid, what is the maximum volume of carbon dioxide produced? Alright, so here we have a mole question. These can be a bit tricky in multiple choice tests, so let's see what we can do here. So we've dilute hydrochloric acid in excess. That means all 26 gram of sodium carbonate will react. It looks like we probably should look up the MR, the relative molecular mass or the relative formula mass of sodium carbonate. So we have 2Na plus the relative mass of carbon plus 3 times oxygen. Na has a, if we check the periodic table, it has a mass of 23, carbon has a mass of 12, oxygen has a mass of 16. So that's 2 times 23 plus 12, so not times 12, some brackets, it's nicer, plus 12 plus 3 times 16, that is 46 plus 12 plus 48, that is 60, that's 106. Yes, 106. That's the relative mass of sodium. We have 26.5 gram. So we know molar mass is equal to mass over moles. We are looking for the number of moles. That means 26.5 over 106, and that should be around about 0.25, a quarter. So what else do we know? So we have a 0.25 moles. We can see the mole ratio between the two is 1 to 1. That means we have 0.25 moles of carbon dioxide. We know that 1 mole of a gas at room temperature and pressure has a volume of 24 decimeter cube. That is a constant at room temperature and pressure. Every gas has a volume of 24 decimeter cube. So we don't have 1 mole, we have 0.25 moles. So what we do is we times, to find the volume, we times 24 by 0.25, and that is going to be 6. So the correct answer is 6 decimeter cube. Number 9, a volumetric pipette is used to measure 25 centimeter cube of 2 mole per decimeter cube aqueous sodium hydroxide into a conical flask. The burette is filled with dilute sulfuric acid. The equation for the reaction is shown. 2NaOH plus H2SO4 gives Na2SO4 plus H2O. The reaction requires 50 centimeter cube of dilute sulfuric acid to reach the endpoint, to neutralize it. What is the concentration of the dilute sulfuric acid? So we can again do a mole calculation here, another mole question. We are given the volume of the sodium hydroxide solution and its concentration. So we can find the mole. To do that, we should change the volume to decimeter cube first. So 25 centimeter cube divided by 1,000. Let's do this on this side here. Is equal to 0.025 decimeter cube. We have 2 mole. We find per decimeter cube, so concentration is equal to N over V. We are looking for N, so N moles is equal to concentration times volume. So that is 2 times 0.025, which is 0.05. moles. The mole ratio, however, is up here, a 2-to-1 ratio. So to find the number of moles of, this is for NaOH, to find the number of moles of H2SO4, we need to divide this by 2. So we have again 0.025 moles, and we do know the volume, which is 50 centimeter cube. Again, we divide this by 1000, which is 0.05 centimeter cube, and we find the concentration by calculating moles, which is N over V, so 0.025 over 0.05, and that is equal to 0.50 mole per decimeter cube, and we can see this is answer A. So I think these are enough questions for this lesson. In another screencast we will have a look at the remaining 31 questions up to question 40. Until then, I hope this screencast helped you a little bit with your preparation for your IGCSE exams, and I see you next time. Have a good day.